and welcome to another video. In this video, I'll be explaining what point of contraflexion means. What we have on the board, we are familiar with it. This is the shear force diagram and bending moment diagram for the previous class. Okay, now first, there are these points we need to know in shear force and bending moment diagram. The first one is the position where the maximum bending moment occurs, while the second one is the point of contraflexion, also called point of inflection. So by definition, or what does it mean for the position where the maximum bending moment occurs? Position where the maximum bending moment occurs simply means a point where the shear force cuts the x-axis, right? Meaning at that point, shear force value is 0. Similarly, point of contraflexion means it is a point in the bending moment diagram where the bending moment cuts the x-axis. Meaning for that bending moment diagram, the point there where the bending moment is 0, then that point of contraflexion is said to occur. And that's what we have here. This is the bending moment diagram for this loaded beam. Then we said point of contraflexion, it is a point where the bending moment is equal to 0, or where it cuts the x-axis. From what we have here, at this point, from A to B, which is length 5 meters, at this point, point of contraflexion has occurred at that point. Meaning that at this point, the bending moment cuts the x-axis, and we can see that the bending moment is what? 0, maybe 0 at this point. So we want to get the value from A up to this point, right? Let's give that x. Meaning we have to calculate the value of x. So we know the value of x, that means we've been able to obtain the value where the point of contraflexion occurs. So that's the idea behind point of contraflexion. But looking at this shear force diagram, we don't have anything that is related to the definition. Meaning at this point, bending moment does not cut the x-axis, neither the value of bending moment is equal to 0. Right? In the next example, we'll be doing shear force. We'll be calculating the position of the maximum bending moment and also point of contraflexion. So, solution: how do we then obtain the value of x? Now, we already know that we are to calculate the value of x. Any value that I get for x, it means that's the point of contraflexion. Okay, solution. When it comes to point of contraflexion, the idea is you redrawing the loaded beam, then putting the bending moment on it, right? Just like you bringing this bending moment diagram on this loaded beam. Let's see what we have by doing that. We have this. This is 2 kilonewton. This is 2 meters, and then this is we have a UDL. We have a point load. This is 5.5 kilonewton. This is 2 kilonewton per meter. This is 2 kilonewton per meter. The distance from here, 2 meters, 3 meters, right? I'm done. Okay. R is equal to 7.5 kilonewton. RB is equal to 10 kilonewton. So what we did here, this is the loaded beam. Then we have to put the bending moment diagram on it, how it varies on the length of the beam. Okay, so I'll be having something of this, right? From here, this is my interest. From this is A, this is D, this is D, okay, this is B, this is C. So my interest now, it is from A to what's the position or what's the length from A up to where this point of contraflexion occur. Then how do we do that? So now, to calculate the value of x, first step, we are going to section the beam at a distance x from the left hand support. Okay, meaning we are sectioning the point where the point of contraflexion occurred. We will be sectioning that point. That's what we do here. Section it xx at a distance x from the left hand support, right? The next step is to take moment about that point being sectioned and denote the moment as mxx, meaning we are taking moment at this point, right? Neglecting this part. That's what it means. Normally when we are taking moment, we are meant to consider this place and this place, but because we've sectioned, neglect this part, then take your moment from here all the forces up to this point. So that's the idea. Now it means mxs is equal to r is going to that point and it's covering a distance of what? X meter. Meaning I have, and the value of r is what? 7.5. Meaning I have 7.5 times x, right? Also I have a point load going towards this direction. But observe, from A to that point is x, right? From this point load, meaning from C to this point where you are taking the moment, is unknown. But when we know that the total distance is what? X, and we know that from A to C is 2, meaning from C to that point. Okay, let me call that point. Let me denote it as G. Right? What it means is that AC plus CG is equal to what? AC plus CG is equal to what? AG. And the value of AG is what? X. Let me substitute the value I'm having. AC is 2 plus CG is equal to what? X. This implies that CG is equal to what? X minus 2 meter. Meaning from C to G, which is the point, the section, we've taken the section, it means the value or the distance is x minus 2. So that's how it works. So from here now, what that means is from here to here is what? X minus 2 meter. Right? Now taking the moment of 5.5 kilonewton up to that point is going in what? Anti-clockwise direction, meaning negative. So I have minus 5.5 all into bracket x minus 2. But I'm not done with all the forces there. I also have a UDL of intensity 2 kilonewton per meter, and the length in which the UDL cover up to that point is x. It's also going in anti-clockwise direction, meaning I have minus 2 times x, converting into a point load, then simply multiply by the distance. Then equating mxs to 0. Meaning I have 7.5x, right, minus 5.5x plus 11, then 2 can cancel 2, we have minus x squared is equal to 0. What I have here, this is giving me quadratic equation. Then let me rearrange. First, before rearranging this, 7.5x minus 5.5x, that's 2x. So I have 2x plus 11 minus x squared is equal to 0. Then I have x squared plus 2x plus 11 is equal to 0, which implies x squared minus 2x minus 11 equal to 0. Let's call this equation 1. So what it means now, the next thing we need to do here is to get the root of this equation. Meaning we have to get the value of x for this equation, and that's what we need to know, value of x, which is from A to that point where the point of contraflexion occur. So that's it. Now how do I get the value of x? I can use okay, first comparing this to quadratic equation, which is A okay, let's just comparing this to quadratic equation. From here, A is equal to 1, right? B is equal to minus 2, and c is equal to minus 11. Then we call this formula minus b plus or minus square root of b squared minus 4ac over what 2a. Then from here, the next thing we just need to do is to input the value of a, b, and c. Then we get our answer. Okay, let me do that here. Okay, from here, I have minus open bracket, the value of b is minus 2 plus or minus square root of minus 2 square minus open bracket 4 times a is what 1 times 6 what minus 11 divided by what 2 times what do I have? Okay, 2 times 1. Then from here I have 2 plus or minus square root of this is 4 minus open bracket 4 times 1 4 4 times minus 11 is what minus 44. Then minus times minus 44 simply means plus 44. Sorry, let me come again. 4 times 1 is what 4 times minus 11, that's what minus 44. Then minus times minus 44 simply means plus 44. Okay, meaning from here I have plus 44 all over 2, right? Which means 2 plus or minus square root of what 48 all over what 2. Now from here, x, the value of x is equal to what 2 plus square root of 48 all over 2, or x is equal to what 2 minus square root of 48 all over what 2, right? So from here, the square root of 48 is 6.93. Let's confirm that. Okay, 6.93, meaning I have 2 plus 6.93 divided by 2, or 2 minus 6.93 divided by 2. Then I have 8.93 divided by 2, or minus 4.93 divided by what 2, right? Okay, from here, 8.93 divided by 2, I'm having x is equal to 4.67 meter. Okay, sorry, x is equal to 4.47 meter, or x is equal to 2.47 meter. Okay, we've been able to calculate the value of x, but we got the value of x in two forms, meaning x is equal to 4.47 meter and x is equal to minus 2.47 meter. But what we can see here, or what we know here, is the value of x does not going to be negative, right? The value of x is positive, meaning from here to here it was 5 meter, and we said point of contraflexion occur at this point. What it means is that the value of x will be what less than what 5, but it will also be closer to what 5, meaning x is equal to minus 2.47 meter is what it is wrong. So therefore the value of x in this case, which is the point where the point of contraflexion occur, is what 4.47 meter from the left hand support. From the left hand support, and the left hand support in this case is A, that is A, right? And you can also get the value of the x by saying 5 minus 4.47, which is equal to 0.53 meter, right? meter, which means x is equal to what 0.53 meter. Okay, from the what? From the right hand support, meaning B, from the right hand support, that is A. So in conclusion, the value of your point of contraflexion, the position where it occurs is 4.47 meter from the left hand support, that is A, and what 0.53 meter from the right hand side, meaning B. So it makes sense, right? Because from here to here, if you consider from here to here to be your x, it means you are going for what 4.47 meter, and if you consider from here to here to be your x, meaning you are going for 0.53 meter, at the end of the day, by the time you sum it up, you will still get the value of what you still get 5, which is the value for the total length. So that's how it works. That's how you calculate your point of contraflexion. Also know that the point of contraflexion is also called point of inflection. Take note of that. So in the next video, we will take another example using it to explain how you can calculate the value of the maximum bending moment, also point of contraflexion. Okay, see you in the next video.